I'm doing problem 4 from the first test, and I found this particularly difficult because I wasn't able to set up the integral under the time constraints of the test. So the first thing you need to do is determine the vector of your E field, and to determine that you look at the observation location that you're looking at, which is the star point here, which is 0, oh no, sorry, W plus L, comma 0, comma 0, because it's this distance plus this distance, which is a point star, and then it's on the x-axis, and then that's your observation location, and then minus the source, which is any point along the rod, which is just 0, and sorry, not 0, x, comma 0, comma 0. So the r vector is equal to W plus L minus x, comma 0, comma 0. And then so if you're integrating the each charge on the rod to determine what the total rod is, you have to determine a charge in an infinitesimally small part of the rod. And then so that is just a linear charge density, which is Q over L is equal to dq over dx. And then so you know that Q over L dx is equal to dq. And then so now if you try to integrate each point on the rod, you have to integrate dE to determine the whole rod, the electric field of the entire rod, and the electric field of one point along the rod is just dq over r, magnitude r squared, times r hat, times 1 over 4 pi epsilon naught. This simplifies to 1 over 4 pi epsilon naught times q over L over W plus L minus x quantity squared times x hat. And that's the answer to part A. And now so to solve the problem, you have to actually integrate the dE. And so if you integrate dE from 0 to L, you get that it's equal to the integral of 0 to L of 1 over 4 pi epsilon naught times Q over L over W plus L minus x quantity squared. This simplifies to 1 over 4 pi epsilon naught. You can pull the constants out, times Q over L times the integral from 0 to L of 1 over W plus L minus x quantity squared times dx. And so if you solve this integral, you have to use a u substitution. And so if you use the u substitution, u is equal to W plus L minus x, then du is equal to negative dx. And you solve the integral, it simplifies to Q over L over 4 pi epsilon naught times the integral of 0 to L of u du over u squared. And then if you integrate that, you determine that actually it's a negative sign because it's negative dx. And so if you integrate this part of the function, you determine that it's negative u to the negative 1 times negative 1, which actually just simplifies to positive. So it's 1 over 4 pi epsilon naught equals Q over L times 1 over 4 pi epsilon naught times 1 over u evaluated from 0 to L. You substitute u back in, you determine that it's Q over L over 4 pi epsilon naught times 1 over W plus L minus L minus 1 over W plus L minus 0. And then so you simplify this, it just comes to Q over L over 4 pi epsilon naught over actually I messed that up. If you use the common denominator, you get that it's 1 over W times L plus W. have your solution.